What we have here is a very typical exam question, shows up on PRE-CALC or trig algebra 2. We're given 4 functions to graph and 8 graphs to match it with, and this particular clip is the last of the 4 series. I've covered the other 3 functions earlier, and this one will focus on part D. Let's get started. Looks like I have a lot of stuff going on the slides, but the first thing you want to do is really take a look at the function and graph to see if it's a rational one. It's with a division, so if you have a division over here, that's a rational. If it's a polynomial or not, that's more of adding and multiplication. In our case, part D, what we're looking at is definitely a polynomial. With a rational one, since it's a division, that's very important. You look at the denominator and finding the wholes and go from the wholes, looking at what the vertical asymptote behavior is, and then you look at the horizontal asymptote behavior, and then you look at the special value, which I covered in the last 3 videos. Now, this particular one is a polynomial, so we won't have any denominator. That's a telltale, a big one. We're going to move on to on this side, polynomial. The polynomial is actually easier to graph in that there's only just the 3 big things. You're going to take a look at the leading coefficients. If it's up, then the leading coefficient is positive. If it's negative, then the graph is going to face down. Obviously, ours is negative, so it's going to be facing down. It's not going to be this one. We're going to look at the roots and multiplicity. If it's multiplicity of the roots is even, it's a smooth one and it does not cross x-axis. So for our case over here, x minus 2, the roots will not cross the function, the graph will not cross at x equal to 2. And the last one, of course, we always want to stop, end with the special value. When x is equal to 0, we want to take a look at what happens to the function. So let's take a look at this last part D in detail on next slide. All right, so let's make some room for ourselves and move these things around a little bit. So here are the steps to do the rational ones, and here are the steps to do the polynomial, which is what we have. Let's go through one at a time. All right, so let's look at the steps. Once again, it's not a rational, there's no division, it's a polynomial. So the function here is all multiplying over here. And the leading coefficient is minus 1/8, so the graph will be facing down. Basically, when x is really big, what we can see is the graph is going to be facing downward. When we do a quick analysis or summary, we can blow up the graph. You can see here's the graph facing downward. The ending point is not facing upward, so it's not this one. All right, and moving on to next one, multiplicity. When you set each one of the terms equal to 0, that's where the roots are. X equal to 2, that gives this part equal to 0. Because the power of square over here, the multiplicity is even, because 2 is an even number. So when the graph at x equal to 2 will not puncture the x-axis at x equal to 2. When x equal to minus 3 and minus 5, for the other 2 roots, as you can see, the graph does cross x equal to minus 5 and x equal to minus 3. Last one, special value, when x equal to 0, that's when it crosses the y-axis over here. If we evaluate and plug in 0 for x, we have that 0 and minus 15.5 is a point on the graph. So let's do a quick analysis, a quick summary, and we'll see the graph in a larger picture here. So here's the summary. We're looking at the p of x. It's a polynomial, so there's no breaking or there's no holes, I guess. The special value we calculate in step number 3 is 0 and minus 15.5. That's this one over here. From step number 1, called leading coefficient is negative, so the function is facing downward. If you imagine this as a cup, some sort of funny cup, this thing is facing downward versus where this one is facing upward. And one more thing is from number 2, when the multiplicity of this root x equal to 2 is even, it does not cross x-axis, unlike the ones from minus 5 and 3, which produced it over here. That does cross, the function does cross x-axis at minus 5 and minus 3, but it does not cross at x equal to 2. And the leading coefficient is showing green over here. Well, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment, share, or hit like button on this video. Together we can make math easy again. Have a confident day.